Okay. All right, ladies. The next topic is they're called rate of change problems, and there should feel. Listen, they should feel a little familiar. They're extremely similar to the velocity and acceleration problems. In fact, they are the same thing as the velocity and acceleration problems, but they're not about velocity and acceleration. And they tend to be very wordy, okay? Lots of words and nasty equations. They give you these nasty functions because they're testing your calculator skills there. So before we get into them, before I actually take you through a few, we're going to talk a little bit about units. And I did this in class before, but I'm going to just hit it one more time. Okay?
Did you start going this one?
I think I did. Yes. That's good. Okay. All right. So if I give you in words a function, and in the words it tells you that this function is dollars per hour. Okay. I don't know what it would be, but there's all these words there, and the bottom line is this is dollars per hour. If you have established that, then tell me what would the units be on f prime? If you take the derivative of dollars per hour. Dollars per hour. Per hour. Like meters per second. If you wrote dollars per hour squared, that would be fine, but you lose the intuitive part of this. The dollars per hour are changing. Okay? All right? Also, what would this be? What? Is there a question?
Oh, just AC. Maybe.
Yeah. Okay, I'm happy to turn it on, but then it's loud. Okay. So you want to open the window and see if that helps? I will turn it on, okay? So what would it be if you took the antiderivative of that original function? Okay? What am I going to get if I take the antiderivative of dollars per hour? I'm going to get dollars. So if you get all these words, and you determine these bits of units, and I say, how much money, blah, 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 blah. That's this one. Okay? If I say, at what rate is F changing, that's this one. Okay? So you're going to figure these units are really going to help you figure out which one of the things you're supposed to do. One of the things they've started doing fairly recently is they'll write something like this and say, what does this mean? They don't ask you to find it. They say, tell me what this means. There'll actually be numbers here from 3 to 10 or from 50 to 100 or something. So what does it mean when I take the definite interval of dollars per hour? There's a particular language I want mine to get in here. There's a big word that needs to be in here. Not rate. Increasing. It's the amount of change. It's how much this changes. Amount of change. From A to B. It's going to take you back to an unnamed function. Like there's no name particularly for this function, so you can call it something if you wanted to. But you're going to take it back to this other function and plug in B and plug in A and subtract. It's how much something changes. All right? And the units are still going to be dollars. What's this? Connected to me over there. It's the average value. Of what? It's the average value of whatever, right there. It's the average value of F. So what are the units going to be on that? Well, the antiderivative units are dollars, yes? And I'm dividing it by time, so it's dollars per hour, the same units as the function was originally. Does that make sense? Okay. We'll do a different one. There's a lot of things that flow water flows in the G, gallons per minute. Water flows in, water flows out. Oil is flowing through the system. They love flowing things. Okay? So, what would G prime measure? Gallons per minute. Per minute. The rate of change of the gallons per minute. Like turning the faucet on and then opening it up so it flows faster and closing it up so it flows slower. It's still flowing, but how it's flowing changes. Okay, what would the integral of G of T dt be? Gallons. So if they say, how many gallons? Well, definitely you're going to take the integral. And this, 1 over B minus A, integral from A to B of G of T equals, tell me what it is first of all. Average value of what? Of G. It's the average value of G. So it's going to be gallons per minute. Okay? Whereas just this, the integral from A to B of G is what does it actually measure? Amount of change. Okay, amount of change. Amount of change. You can say that for all of them. And then you can tack it into the problem. Amount of change in the units would be gallons. So how much did the gallons change? How much water entered the system? How much water left the system? Okay? All right, and I'm not going to put the velocity and acceleration ones up here, but we did that when we did this velocity review. We had, this one was velocity. Yes, the top one, for our people at home, this one was velocity. And this one is the derivative velocity, which is acceleration. And this one is the anti-derivative, which is position. It's the same thing. Does everybody see? Yes? Okay. A little bit more on this, and then we'll get to an actual problem. If I give you this information, and sometimes it's this uppercase, lowercase thing, and sometimes it's two different letters. And I say take the antiderivative of big F. That's the same thing as taking the antiderivative of little f prime. Yes? That's the same thing. And what's the antiderivative of f prime? That's right, Joey. Say the letter. It's the little one, okay? It's the little one, yes? And since this is an indefinite integral or an antiderivative, I need to say plus. Okay? Sometimes they say little f prime equals g, like on those things we did before. So sometimes that's the case. I'm sorry, they should still be x's. I apologize. Thank you. All right. Thank you. So what about this? There it is, amount of change from A to B, okay? And according to my definition at the top, when I antiderivative, that's not a word, anti-differentiate big F, I'm going to get little f. And I'm going to plug in B, and I'm going to plug in A. And looky there, what is that? Amount of change. Do y'all see? So even if you don't always see it, that's what it always is. Amount of change. How much did it change? All right. And we're all going to get this right. Don't say it out loud. I tell you where it starts, yes, and I tell you what's this, amount of change, what is that going to give me? That's a V. It's going to tell me where it is now. It's new value. We just did this about 6 times. Yes? I want to find a new value. Start where did it start? Add the amount of change. Is everybody good with this? Number. All right, some radius somewhere in the universe is changing according to a function R of t. Oh. Okay. Rate of change R of t. All right, so if I take the antiderivative of R of t from 0 to 5, what will that tell me? Amount of change in the radius. So this is we're going to plug in what it actually is. How much the radius changes, amount of change in the radius. And then what do we say? What do we have to say after that? From t equals 0 to t equals 5. Or since the first one's 0, you can say in the first 5 seconds. Okay? You can say in the first 5 seconds. You can do that if that's a 0. But you can also say t equals 0 to t equals 5. Alright? If I say, find the average rate of change of the radius equals 0 to t equals 5. Get up to the negative position on. Okay. Alright, you written something down? Average rate of change in the radius. Okay. So, if you can try to plug into here the word, please, if you can plug into here, they're not going to do it for you, the average value of the rate of change, and you'll get these right or wrong. The average value of the rate of change of the radius means 1 over u minus a, integral from a to b, of the rate of change of the radius. That's what you do. Okay, so what's b minus a in this problem? And what's the formula for rate of change of the radius? Big R. The thing that makes these hard is that there's often a couple of equations floating around. You have to decide, am I supposed to use big R, or am I supposed to use little r? Okay? Am I supposed to use S, or am I supposed to use T? They love to keep changing the names. Okay, so we're going to crunch through a couple now to see what happens. Let's actually work. 2004. There we go. 2004A, number 1. For these tend to be calculator questions, but I have 2006B. It was a new calculator question, so we need to do 2004A. It in the area volume. Okay? So first of all, horrible function. Okay. I sound like they like things to flow. This time they're talking about traffic flow. Okay? How many cars flow in and out of an intersection? They come in and they come out, okay? and they tell you the flow at a particular time is defined by F. And I'm telling you, ladies, I started teaching this way about 4 years ago. I got it at a conference. I put it on my own, and then I discovered that other people have been doing it for a long time. And everybody's grades on this kind of problem went from 1s and 2s to 4s and higher. Okay, so this is what you need to do. You need a little section where you tell yourself what this function measures. Never mind what it is. What does it measure? Cars per minute. And you might note that T is in minutes. That tells a little bit. Okay. And before you ask, they're going to ask you to do a couple of things. They're going to ask you to do multiple things. So just stop and say, what am I going to get? What are my units going to be if I take the derivative?
Cars per minute.
Per minute. The rate of change of the cars per minute. What are my units going to be if I take the antiderivative? So if they ask you how many cars, what are you going to do? Take the antiderivative. If they say how is the flow rate changing, you're going to take the derivative. They have given you the velocity, and they're going to either ask you to find the accelerator for two positions. That's basically what's going on. Okay? All right, so let's go back up and read the first question. What does it say?
How many cars are there?
How many cars? How many cars? What do I need to do? Addition, antiderivative from 0 to 30 of f of t dt. Where is f of t going to be? Where's it going to be? You can put it in your calculator, line 1. Okay? Put it in your calculator, line 1. Let's set these up again. We set up the whole ABCD, and then we'll pause so the video's on pause. Okay? All right? B. What is it asking for? Is traffic flow increasing or decreasing? Okay, first of all, what letter is assigned to the word traffic flow? F. Is it increasing or is it decreasing? So what you can look at to determine if a function is increasing or decreasing? If you have a graph, but in general, f prime. So you need to look at the sign of f prime. You can look at the graph. That's a way to do it. If you want to draw the graph. But specifically, where do they ask us? At 7. So how about if I just tell the calculator to tell me f prime is 7? How are you going to tell the calculator to do that? At A on the home screen plugging 7, yes? Okay. All right. Question C says, what is the average value of the traffic flow? And then they change the times on you. And half the people who took the exam kept doing 0 to 30. But they changed the times on you. What do I put? 1 over 3 minus 10 of t. That's going to be on the calculator, yes. Okay. And the last question says, what is the average rate of change of traffic flow? Hold on a second. Average value of rate of change of traffic flow. Here's where your reading and analysis skills come in, right? Average value I got, that's 1 over B minus 7, right? Interval from A to B. Yes? That's easy. What is this? What is the rate of change of the traffic flow? It's f prime. So if you just yep. Hold on for a second. This is going to be a big time saver here. First of all, you had to get that you were doing the antiderivative f prime this time. That's a language issue. Okay. No calculators necessary. You take the antiderivative of f prime, what are you going to get? F. And then you're going to plug in 15 minus 10. So you get f of 15 minus f of 10 divided by 15 minus 10. Yeah, this is your basic slope formula, okay? All right, so I'm gonna hit pause on the recording, give everybody a chance to compute these values. Okay, so, y'all, will need to call one of the people who's here, which was, everybody but Lexi, Lily, and Sandra, and they'll have the answer to that, okay? All right, next problem. Okay, everybody turn to 2004B and see if you can find this question. You know, part of it is recognizing that, oh yeah, this is one of those we worked on. Okay? Find this question. Yeah? Two? Okay? All right, so 2004B. Number 2. Is this a mosquito question? Yes. 3. So, number 2. So first of all, read the question. Yeah, we're not there. Okay, so the first thing you want to do, of course, is read the question, and as soon as you see that horrible function, that's going into Y1. Yes? And they are giving you a rate of change. You know, the whole first half of this review was about a graph that was a rate of change. The only difference in these questions and the ones we did the first half is that they're giving you the information in words and a function instead of giving it to you in a graph. They are the same problem. They really, really are. Okay? So read it. Take a second to put that function into Y1. Take a minute to put your units down. What are the units for the critical pieces of information in this problem? Okay? R is a rate of change. It's like velocity. Okay? So what are the units for T? Units for R and T? Mosquitoes. Today. R prime? Rate of change of the rate. And what would the antiderivative of R be? Now, one of the things that people sometimes find helpful is to name this function, to give it another name. Okay, and occasionally the AP will do that for you, like they sometimes put it in part B. Well, if M is the number of mosquitoes on the island, and so you might consider the possibility of naming M of T is equal to this thing. Sometimes that's helpful, and it's not necessary. All right, so we're going to do the same thing. We're going to write down how to answer these questions without pushing any button on our calculator. So A says, show the number of mosquitoes is increasing. They told you it's increasing. If you get something different than that, you did it wrong. How do you tell the number of mosquitoes is increasing? Or do you look at the derivative of the number of mosquitoes? What's the derivative of the number of mosquitoes? R, the one they give you. Yes? So we need to know is R of 6 should be positive. And so you can just do that on your calculator. Show what you get for R of 6. Now, what happened there is that they didn't give you a name of a function for number of mosquitoes. You had to recognize that this is the derivative of the number of mosquitoes. Okay? Second question says, at 6, is the number of mosquitoes increasing at an increasing rate or increasing at a decreasing rate. What are we looking for there? You already know it's increasing. R prime, that's exactly right. So we need to find R prime of 6. If it is positive, then that's the second derivative is positive, meaning that it is increasing at an increasing rate. If it's negative, it's increasing at a decreasing rate. So we need R prime of 6, and we need to look at the sign. Okay? Look at question C. All about words. How many mosquitoes will be on the island at time 31? How many mosquitoes will be on the island? Time 31. Mosquitoes at time 31. I'm going to name this function is.
The last.
Be the last one. What do we have to put first? Put the initial value, and that's the thing people listen, and they have to give it to you. Go back up and read the problem. 1,000. Yeah, there were 1,000 at the beginning. At time 0. And then we are going to do the antiderivative from
0 to 0.
the 31 of m prime, and m prime is R. You don't have to call that m of 31. Just sometimes it helps me to give it a name. Number of mosquitoes at 31. How many were there at the beginning? Plus how much did it change? Everybody say? Yes? Nice and loud.
I don't get, I mean, I understand number A, but how, or letter A, but how do you know to use R2?
Instead of R prime?
Yes.
Okay, this is that business of understanding that R is mosquitoes per day. And so somewhere there's a function that they didn't name called M, which is mosquitoes. And M prime is R. It kind of goes back to that, you know that graphing where they gave you that funky G of X equals the interval of F of T thing, and you have to say, oh, G prime is F. That's kind of what's going on here, only with words instead of the symbol. Okay, so you had to recognize that R is the derivative of how many mosquitoes. Okay, that's the trick to it. And I don't want to, I'm not going to, that is the trick. That's the place where people mess up the most often.
Then you would say mosquitoes was the antiderivative of R2?
Yes, since mosquitoes is the antiderivative of R, then R is the derivative of mosquitoes. Okay, is that helpful?
Yeah.
Okay, so what's the next question?
Max.
Oh, maximum, huh? If I want to find the maximum, ladies, the maximum, I better find out how many mosquitoes were there when we started, which was 1,000. I better find how many mosquitoes were there when we ended, which I just done find in part C, right? Yes? Then what else do I need to find? This is just a down. Okay, at the beginning there were 1,000, at their end there were something. I'll have that number from here. What else do I have to look at? Relative max. Okay, so how do I find the relative max for the number of mosquitoes? Wait a minute, number of mosquitoes is M. With M prime is R, changes from positive to negative. This is the same question Annie Carson just asked us if y'all weren't listening to the answer. Everybody listen, okay? I want to take where the derivative of number of mosquitoes, okay? And Kristen pointed this out, and if you'll call this M, like the antiderivative of R is mosquitoes, and the derivative of mosquitoes is R. So I want to know the maximum number of mosquitoes. I need the derivative of mosquitoes. That's R. R changes from positive to negative. And I think I did that on the graph. I'm pretty sure we did that on the graph. Okay? So you're going to get a graph from this, graph R, and get some X value. Yes? And then how are you going to find the number of mosquitoes at that time? What are you going to start with? 1,000 plus the integral from 0 to whatever you get of R. Okay. You also remember, this is, not only is this like the velocity and acceleration questions, it's also like the one we did in the first half of class, only from functions instead of shapes, okay? I'm gonna hit pause, and everybody's gonna work on these. Okay, we're now going to the 2005 exam, 2005A. See if you can locate the question. Similar to this one. Similar one. Look here, 2005. Three. Okay? All right, ladies, so here's what I heard. I think it's number 2. Okay, and your sort of your clue to that is nasty functions. But also when you read the descriptions, both of those functions R and S are already rates of change. What are the units for R and for S? Unit charge per hour. They're giving you velocity. Y'all see? Okay. And then I heard somebody say, or maybe number 3. Okay? And the answer is that's because number 3 is kind of sort of the same problem, only they've done it with distance and they gave you a table of values. 3 of the 6 questions are likely to be related to the concepts that we've done today. Velocity acceleration is the same thing. The graph of G prime, it's the same thing. These wording problems, it's the same thing. So you're likely to have 3 where you've got to pull all of this information together from different stuff. Here's a table, here's a graph, here's a function. Okay? That's all I'm looking at right now. Okay? All right, so once again, you're at home, you're looking at 2005, the first form, it's question number 2. Okay? And some of y'all are saying, well, we're doing another one. And we're doing another one because one of the other favorite things they like to do with these flow problems is have stuff flowing in and stuff also flowing out at the same time. Okay? So it's coming in at one rate, it's going out at a different rate. So this is one other particular thing we see. So R is cubic yards per hour. I would write yards cubed per hour. And I personally would put something on there, making sure I remember that this is the amount of sand that goes in or out. Out. Okay. ST is yards cubed per hour, and it is sand coming in. On both of them, T is hours. I'm going to try this one more time. This is the thing that causes the most trouble. I'm not going to say it's the hardest, but it's the thing that causes the most trouble. Okay? This is a rate of change. It's like you've been given velocity. So you have to be prepared to go forward to acceleration. Yes? And backwards to position. So when we go forwards to acceleration, what are we going to call that? R prime. We're going to call that S prime. One thing at a time. Okay? And that'll be yards cubed per hour per hour. The rate of change of the rate of change. Rate of change and the rate of change. However, you want to write the units twice, or you can write them. You've got to be able to go backwards to position. There is a less obvious choice for what you want to name that. We name position X, Y. Physics, they like to call it S or Y. Okay? It feels to me like we might want to name it something. I don't know. You want to name it something? Okay. It's up to you. Some people get by with this without ever naming it at all. This is how much sand there is. How much sand went out, how much sand went in. Sometimes they will name it something. Oh, yeah, read question B. Read question B. Okay, they have given this a name, okay? But sometimes they don't. You can if you want to. Just like when you've got the velocity and I say, well, what's the position? You write X. If I say, blah, 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 sand, blah, 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 and I say, how much sand? You could write, I would use S, because it's already over there. You could write something. Does that make sense to everybody? Okay, nice. It is a little bit tricky. Okay. We got our units on here. We're done into this a little bit. What is the first thing they told me something also. At the beginning, there's 2,500 cubic yards of sand sitting on the beach. Okay? Question A. How much sand will the tide remove during this 6-day period? Write it down. How much sand will it remove? Write the math down. That's the amount of change. How much will it remove? Do I get it? How much sand? The answer's got to be the antiderivative. Yes? Why did I pick R? That's the act. Very good? Okay. Now here's going to be a little clue that you're going to have to pick up on. If this answer is a negative number, then the negative has been included in the function. If it is a positive number, then the negative has not been included in the function. Everybody understand? So you just have to watch out for that. Okay? Well, if this came out to be negative 54, that just means 54 cubic yards were removed. Okay? Whereas if it came out to be positive 54, you know that, okay, they didn't put the negative in. Okay? All right, second question. They've asked you to create a function. Make sure you feel very comfortable. What is this function supposed to represent? All the sand, all of it. What has to go first? So initial value. So we're going to start with, they're starting out with 2,500. And then what happened? How much it changed? How much did it change?
Plus.
So the interval from 0 to 6 of what?
0 to 10.
Yeah, of how much went in minus how much went out. And this does turn out to be a positive number, so you have to put a minus. Okay. There is no 1 over T. Where did I write 1 over T?
1. Oh. Why did you choose 6?
This is 6. Doesn't it say 6?
Well, it just says a times 2.
Oh, shoot.
Yeah, so isn't it T?
Let me read it again. Okay. So, yeah, there's a couple of ways you could do this. Sorry. Okay. Thank you very much. Okay. That would have been how much sand is there in times 6. Okay. Now this. And everybody understand that there's a little problem right here. Yeah, I've already used T over here. So this needs to become what? X. This needs to become X. And this needs to become X. Because when you take the antiderivative, it'll become T. They were fairly generous in their points. So they didn't, as long as everybody finished, whoever got this problem finished this up all right, they didn't take off. That was the only mistake that's on. Does that make sense to everyone? You can't have T's here and plug in T's here. So what do I want? Say that again. Okay. The question is, let me make sure we hear the question. Should this be y of t or y of x? I want everybody to stop and think. Should it be y of t or y of x? Starts out at x. When I take the antiderivative, it becomes t. And so this is going to be t. All right? Okay. So we actually have already done that one. We don't have to do anything else. We just finished. What does C ask us to do? Rate of change. Rate of change of the total amount of sand. What's the total amount of sand? What is the total amount of sand? Right there. This is the total amount of sand. Why? So how do I find the rate of change of the total amount of sand? Not antiderivative. Y prime. This is what it's asking me to find. Y prime. Okay? And it's actually asking me to find it at times 4. Okay, so now I really want y'all to be very quiet. And just think, if this is y, then what's y prime going to be? Just think. First question, what's the derivative of this? 0. Stop right there. So think about the other one. What is the derivative of the antiderivative? So get you started with, okay? So all that you have to do here is say S of 4 minus R of 4. Okay, I shouldn't say that. I shouldn't start any sentence in this unit with all you have to do. It turns out it isn't hard. The hard part is getting past the words, figuring out, do I do R prime, do I do R? That is the hard part, okay? What is the derivative of this antiderivative? That's stuff on the inside. That's a fairly recent concept, okay? And we're going to write down what we have to do for D. We're just going to write down what has to be done for D. What does it ask for? Does it feel like they want a relative n or an absolute n?
Absolute.
Okay, so I think I better find y of 0, and I better find y of 6. And then I'm going to have to find y of some relative n. Yes? Relative min of what? How do you find the relative min of anything? When what changes? The sign of what? Of y prime. I mean where y prime changes sign from negative to positive. Okay? Meaning where y prime changes sign from negative to positive. All right, so what I want you to do right now, I'm going to hit pause again. I want you to get the answers for A. We already did B. Get the answer for C. Then we're going to do the last one together. All right, so A was 31.815 cubic yards. I think this is one of those years where they you had to get units right on all of them at just one point. And then C was negative 1.9 something.
Yeah, I got positive.
And you did exactly probably.
That's 4 minus 1.
That's I'm going to bet that you got the one way in your calculator and you have another way in your calculator. That's what I'm
Yeah.
All right. So all right. So now the last thing we got to do is figure this out, and this way to figure out. Okay. So I'm going to go back up and write this down again. Y is equal to 2,500 plus the interval from 0 to t. So S of x minus R of x. I got that right? I just copied that from my brain. That's the right that's second again to me, yes? Okay, so look lady, what's y prime? Well, what's the derivative of 2,500? 0. And what's the derivative of the antiderivative? S of t minus R of t. So y prime is just S of t minus R of t.
So for the antiderivative.
Okay, hold on a second. Wait. Does everybody follow what I just did?
No.
Okay. They switched to t because I did this interval right here. Okay? All right, so here's the thing. I want to set this equal to 0. I'm going to pause for just a second. I don't think we're all quite following where I am. Hang on. Okay. Question B said, I got to know what question B said. Question B said, oh, absolute minimum. We're finding a minimum. Okay? If you want to minimize, you take a derivative. Yes? Yes? If you take a derivative and you want to find a minimum, you need to find where the derivative changes from negative to positive. So here's my derivative. I'm getting my derivative so I can decide where it changes from negative to positive. Everybody understand what I did now? Okay, so you've got a couple of options available. You've got in your calculator already, these are in y1 and y2, aren't they? So you can turn them off and create a new function, y3, and make it y1 minus y2 or y2 minus y1. And you can draw the graph and look at it. Yes? Okay. The other thing you can notice is that if I just put 0 right here, and I wanted to solve that, it's where they're equal to each other. Can y'all see that? So if you happen to see that, you might save yourself a little bit of time. But the other thing works just as well. So I need to find this value, where the derivative is 0. In this particular problem, happens to be where these two things are equal to each other. Y'all see? Now, that's all it's going to happen. Just a neat little twist. So let's graph it and let's find where are these two things equal to each other. Come up with that number. And you already have a sense of how big your graph needs to go because they throw this number 6 at you. Yes? Speak up.
So I guess that.
I got to hear a question in that game.
So I guess I see what you're doing with the y prime and then making them equal to each other, but how does that relate to y up here, y up?
Okay. Ladies, listen. Okay. The beginning of this problem was to find a min. So that means y at the beginning, y at the end, and y at any relative ends. Try to get a relative min. Y prime changes from negative to positive, and that's going to be someplace where y prime equals 0. Okay? So that's where this is all about.
But how if they're equal to each other, you graph it and then you find.
Right, so they're equal to each other. And you could also have taken this right here and put it in line 3. You looked at it. Okay. Where it changes from negative to positive. I think there's only one in this particular one, there's only 1 0, I believe. One place with the intersect.
When you change it.
I got 5 point something.
Yeah, 5.117.
Yeah, 5.117, some number. Okay? So once you get this, whatever it is, then you want to store that in whatever memory compartment makes you happy. And for me, it's memory compartment. Okay. And then we're not going to even bother doing this because we've done it so many times. Yes, we've done this so many times. How do you find all of these values? Well, the first one they gave to you, yes? The first one they gave you, what was the beginning? 25. And then how do you find this? You see 2500 plus the integral from 0 to 6 of y prime. And then you say 2500 plus the integral from 0 to a of y prime. And I could be talking about this, but y'all are at the end of your rope right now. Okay? What I want, well, we thought of quite a few things, but what I want you to have gotten from this is when I give you one night for homework in about 2 weeks, I'm going to give you a whole response packet. Okay? And I want you, when you go in there, I want you to say, this is that kind of problem. I need to go back and pull that stuff out, look at it again. And you're not going to be surprised if there's 3 of them out of the 6 that kind of feel like this. Graph with G prime, table with velocity, and word with Goldstein. Okay? Or something. Okay? All right? All right. Finish early in the farmer.